Hello everyone, my name is Junda He, and today I would like to introduce our work, namely Pre-trained models for tag, sharpening tag recommendation of Stack Overflow posts with pre-trained models. First, let's talk about the motivation of this work. Established in 2008, Stack Overflow has accumulated more than 23 million questions and 33 million answers. The rapid growth of Stack Overflow highlights the need to efficiently manage the site's content at a large scale and support queries from users. A Stack Overflow post is consisted of title, body, and tags. Tags play an important role in structuring and navigating the content of the site. Accurate tags that summarize the post concisely can help to deliver the question to the appropriate set of people with the right expertise. However, the quality of tags highly depends on user experience and language skills. Poorly selected tags lead to taxonomy and tag explosion. Thus, an automated tag recommendation approach is desired to recommend high-quality tags to the users. We formulate the Stack Overflow tag recommendation task as a multi-label classification problem. We're given an unseen Stack Overflow post with title and body, where the goal of the model is to select the most relevant subset of tags from the total set of tags. The transformer-based pre-trained models such as BERT and RoBERTa have established great progress in the field of natural language processing. Inspired by the success of pre-trained models in the NLP domain, there is an increased interest in adapting pre-trained models to the field of software engineering. Such pre-trained models have been very effective in multi-class or pairwise classification tasks, such as sentiment analysis, API review. However, not much software engineering literature has investigated the performance of pre-trained models in handling a multi-label classification problem with hundreds or thousands of labels. This motivated us to explore whether BERT-based pre-trained models could achieve the state-of-the-art performance in the Stack Overflow tag recommendation problem. Previous SOTA approach is implemented based on a convolutional neural network. Inspired by the recent success of transformer-based pre-trained models, we investigate the effectiveness of several popular pre-trained models in the tag recommendation task of Stack Overflow, which are BERT, RoBERTa, BERT Overflow, CoBERT, and LBERT. Our framework is implemented with the triplet architecture. We split a Stack Overflow post into three components, which are title, description, and code. We first tokenize them and feed it into three separate pre-trained modules. We then apply average pooling on the last layer to obtain the corresponding representation. Finally, we fuse the vectors together and feed it into a neural classifier to predict tag probabilities. We use the same dataset as the previous SOTA approach post-2vec. 10 million posts are leveraged in training, and the testing is conducted on the latest 100,000 posts. We remove the tags, which appears fewer than 50 times. In total, the tag have a size of 30,000. We use the top K precision recall and F1 to report the performance. In the scope of this paper, we aim to investigate three research questions. Firstly, out of the 5 variants of PTM4Tag with different pre-trained models, which one gives the best performance? Second, how is the performance of PTM4Tag compared to the state-of-the-art approach in Stack Overflow tag recommendation? Third, which component of post benefits PTM4Tag the most? The experimental result for RQ1 is summarized in the table. We could notice CoBERT achieves the best performance among the 5 considered pre-trained models for PTM4Tag, and BERT and RoBERTa have also given promising and comparable performance to CoBERT. In comparison with the SOTA approach post-vac, Colbert, Bert, and Roberta all have outperformed post-vac by a substantial margin in terms of all evaluation metrics. Bert Overflow and Albert have demonstrated worse performance than post-vac. For RQ3, we conducted an ablation study on each input component, which are title, description, and code. We train 3 ablated modules and report their corresponding performance. From the table, we could notice that, considering all components of a post, which are title, description, and body, achieved the best performance for the tag recommendation task of Stack Overflow. Title plays the most important role in predicting the top 3 most relevant tags. The lesson learned from our work could be summarized in 3 main points. First, pre-trained language models are effective in tagging Stack Overflow posts. Second, Colbert is recommended as one of the first attempts for software question and answer size related tasks, which involve both natural language and programming language. Third, all components of a post from Stack Overflow are valuable pieces of information. Thank you for your listening.